Imagine the exact moment when humans first looked at the sky, not to worship gods, but to wonder if one day they could reach it. Not just to look, not just to admire, but to inhabit, to cross the black abyss that separates one point of light from another, to expand, breathe, build, exist, beyond. Because deep down, there is something profoundly human in the urge to go beyond limits, beyond the continent, the planet, and yes, even beyond the galaxy. But if we lift our gaze and let it rest without hurry, without fear, a question arises that cuts like the cold of space. Could we really live out there? Beyond the Milky Way, there is an unknown territory. It is not simply another empty space. It is another nature, a region where the laws change, where light extinguishes and radiation does not forgive, where distance is not measured in kilometers, but in impossibilities. And yet, isn't that exactly the place we aim for when we talk about the future? Has human consciousness not always directed itself toward the impossible? This is not a science fiction journey, nor is it escapist fantasy. It is a brutally real exploration of the physical, biological, quantum, and philosophical conditions that would make us possible, or impossible, outside the gravitational embrace of our home galaxy. Here, we will not only talk about engines and spacecraft, we will talk about the void, radiation, consciousness, and meaning. Life as we know it and as we do not yet know it could create a new reality where today there is only darkness. But before we continue, I want you to do something. If this question resonates with you, if you feel the universe is more than a place, and these ideas awaken not just your mind but your soul, then subscribing to the Quantum Observer is more than a gesture. It is joining a community of seekers, of those who are not satisfied with the visible, of those who still have the courage to ask the hardest questions. From here, we will cross the threshold step by step, layer by layer, moving away from the known to ask, with the seriousness of the ancients and the precision of modern science, whether human life can exist outside the galaxy. We live in a cosmic city, even if we cannot see it. A colossal structure made of hundreds of billions of stars, dust, radiation, and something else. Something we do not fully understand. We call it the Milky Way, a poetic name for an entity that is, in reality, fierce, complex, and overwhelming. And yet, like any city, like any home, it has edges, limits. But where does the galaxy really end? Is there a wall, a sign saying, "This far"? No. The edge of the Milky Way is not a line. It is a fade, a diffuse threshold that cannot be measured with a ruler, but with gravitational probabilities, with matter densities that thin out, with the gradual disappearance of the order we can still measure. Most people imagine our galaxy as a flat disk of stars spinning in a spiral, like the images in astronomy books or on universe wallpapers. But that is only a part, a bright, visible, comfortable part. What is not shown is the periphery, the dark halo that surrounds the galaxy like an invisible crown. There, at that border, things change. Matter density drops drastically. The rotation speed of stars behaves unexpectedly, and something we call dark matter, or rather, the effect we feel of it, appears. Because to this day, we have not seen a single particle of this mysterious substance that seems to hold the galaxy together in an invisible gravitational web. Imagine walking through a forest. At first, everything is dense, tall trees, leaves, sounds. But gradually, as you move forward, the trees thin, light enters, and eventually, you cannot tell if you are still in the forest or have left it behind. This is what happens with the Milky Way. The outermost galactic stars are so far apart that entire solar systems could fit between them, and yet they are still part of us. They are under the gravitational rule of the galaxy, still our neighbors, but they are also the frontier, the threshold. Beyond that halo lies the intergalactic medium, a region that belongs to no galaxy, a zone of nobody, or rather, of nothing, at least apparently. But before leaving this cosmic shore, it is worth pausing, because the border is not just a place. It is a question. What keeps the galaxy together? Why do the stars on the periphery not fly away due to centrifugal force? Why does the edge not break? Here appears one of the most striking clues that we understand nothing of what we are seeing. Galactic rotation curves, how stars rotate around the galactic center, do not obey the laws we would expect if only visible matter existed. Something else holds them, something unseen, dark matter, which represents about 80% of the galaxy's mass, but does not shine, does not emit light, does not cluster like ordinary matter. It is diffusely distributed, invisible, in a gigantic halo that extends even beyond what our optical observations can detect. And it is this dark halo that marks the true end of the galaxy. An end that is not a wall, but a whisper, a presence we do not see, but feel. A pressure that holds without showing its face. You are here, inside this giant spiral, in a secondary galactic arm, orbiting at 800,000 kilometers per hour around the center, on a tiny planet, circling a third-rate star. And yet, all this happens within a system, within a gravitational network that keeps you bound to the heart of this stellar city. As long as you remain within this field, you are part of the galaxy. Your body, your time, your history form part of this gravitational and energetic ecosystem. But what if you took a step further? That is the question, because as long as you orbit within the galactic halo, you are, in a sense, protected. Even when it seems you are in absolute void, there are particles, fields, gravitational memories. But as soon as you leave it, you enter another realm, one where you are no longer bound, where time could change pace, where forces no longer recognize you as belonging. The galactic edge, then, is more than a spatial boundary. It is a metaphysical threshold, the difference between being and not being, between belonging and wandering, between being part of a system and being an isolated point in an ocean of silence. And yet, if we want to answer the question of this journey, we must cross it, because only beyond that frontier can we confront the true inquiry. Is human life possible, a life like yours, beyond the invisible embrace of our galaxy? We are about to leave home. There are no maps, no paths, only questions. And in the universe, questions are the best compass. If I told you that what we call the void is not what you think, that the space between galaxies, that immense dark region where it seems there is nothing, is actually filled, not with things you can see, but with something far more intriguing. Fields, scattered particles, invisible structures, remnants of creation, quantum shadows that never touch light. Because when we say we are leaving the galaxy, what we really mean is we are penetrating the intergalactic medium, a region where neither the warmth of home nor the attraction of the known can reach you. The intergalactic medium is the largest known desert in the universe, but it is not empty. It is an ocean of densities so low that in 1 cubic meter you might find only a handful of atoms, and yet that handful represents something. Sum all those atoms across millions of light years, and the result is not negligible. Many astrophysicists believe this space contains a significant fraction of ordinary matter, hidden in dust, filaments, and tenuous clouds of ionized hydrogen. This medium, colder, thinner, more radical than any terrestrial void, is not homogeneous. It has structures. It is like a cosmic web connecting galaxies through invisible filaments of hot gas and plasma. Some call it the cosmic web, a large-scale structure that holds the universe together like nerves in a body. But a body without skin, without flesh, just tendons floating in the darkness. Now pause and consider this. If humanity ever decided to send a spacecraft beyond the galaxy, it would not pass through a clean tunnel, not cross a hallway between 2 points. It would swim for millions of years in this strange ocean, an environment with no suns, no systems, no shelters, where each dust particle might take millennia to find a companion. And here arises a paradox. The farther you are from everything, the freer you are, but also the lonelier, more exposed, more fragile. The intergalactic medium has no magnetic shields, no atmosphere, no stations. Cosmic background radiation, gamma rays from distant explosions, high-energy particles, all of it arrives without filters, without barriers, without mercy. Yet, amid this apparent hostility, there is beauty, extreme, inhuman beauty, perfect in its silent geometry. The intergalactic medium is not empty. It is expectant, full of possibilities, quantum fluctuations that could give rise to new galaxies, remnants of explosions that happened before our sun existed, fields we do not yet understand, but could hold the key to interdimensional travel. Current physics suggests that even in this vast, seemingly inert space, there is activity, movement, presence. The quantum field does not turn off, never turns off, even in the darkest places. At the quantum level, the intergalactic medium simmers with minimal but constant activity, like a deep breath beneath the threshold of all observation. So, could we live there? Could we even traverse it, not as we live here on Earth, but perhaps as different entities, as organisms adapted to radical conditions, as consciousnesses housed in machines that need no atmosphere or gravity, as informational presences capable of operating where matter no longer organizes in cells, but in waves? The question is not only physical, it is philosophical. Is life only what needs a star? Or could we reimagine life as a persistence of pattern, a consciousness sustained not by a body, but by rhythm, flow, a network that adapts and survives even at the edge of nothingness? Perhaps the intergalactic medium is not a desert, but a bridge, not a tomb, but a gestation, a place where the universe is still deciding what to be, where the rules we take for granted crumble, and where a new form of existence may be waiting, silent, patient, immaterial, for someone to arrive and observe it. Yes, you could be the first to imagine it, and that is already a form of exploration. Now that we have left the galaxy and slowly enter this silent ocean connecting the known to the unimaginable, it is time to face one of the most invisible yet relentless enemies: cosmic radiation. In this deep space, where it seems there is nothing, there is something that never rests. An energy traveling through the universe at unbearable speeds. Passing through. The intergalactic medium is the largest known desert in the universe, but it is not empty. It is an ocean of densities so low that in 1 cubic meter you might find only a handful of atoms, and yet that handful represents something. Sum all those atoms across millions of light years, and the result is not negligible. Many astrophysicists believe this space contains a significant fraction of ordinary matter, hidden in dust, filaments, and tenuous clouds of ionized hydrogen. This medium, colder, thinner, more radical than any terrestrial void, is not homogeneous. It has structures. It is like a cosmic web connecting galaxies through invisible filaments of hot gas and plasma. Some call it the cosmic web, a large-scale structure that holds the universe together like nerves in a body. But a body without skin, without flesh, just tendons floating in the darkness. Now pause and consider this. If humanity ever decided to send a spacecraft beyond the galaxy, it would not pass through a clean tunnel, not cross a hallway between 2 points. It would swim for millions of years in this strange ocean, an environment with no suns, no systems, no shelters, where each dust particle might take millennia to find a companion. And here arises a paradox. The farther you are from everything, the freer you are, but also the lonelier, more exposed, more fragile. The intergalactic medium has no magnetic shields, no atmosphere, no stations. Cosmic background radiation, gamma rays from distant explosions, high-energy particles, all of it arrives without filters, without barriers, without mercy. Yet, amid this apparent hostility, there is beauty, extreme, inhuman beauty, perfect in its silent geometry. The intergalactic medium is not empty. It is expectant, full of possibilities, quantum fluctuations that could give rise to new galaxies, remnants of explosions that happened before our sun existed, fields we do not yet understand, but could hold the key to interdimensional travel. Current physics suggests that even in this vast, seemingly inert space, there is activity, movement, presence. The quantum field does not turn off, never turns off, even in the darkest places. At the quantum level, the intergalactic medium simmers with minimal but constant activity, like a deep breath beneath the threshold of all observation. So, could we live there? Could we even traverse it, not as we live here on Earth, but perhaps as different entities, as organisms adapted to radical conditions, as consciousnesses housed in machines that need no atmosphere or gravity, as informational presences capable of operating where matter no longer organizes in cells, but in waves? The question is not only physical, it is philosophical. Is life only what needs a star? Or could we reimagine life as a persistence of pattern, a consciousness sustained not by a body, but by rhythm, flow, a network that adapts and survives even at the edge of nothingness? Perhaps the intergalactic medium is not a desert, but a bridge, not a tomb, but a gestation, a place where the universe is still deciding what to be, where the rules we take for granted crumble, and where a new form of existence may be waiting, silent, patient, immaterial, for someone to arrive and observe it. Yes, you could be the first to imagine it, and that is already a form of exploration. Now that we have left the galaxy and slowly enter this silent ocean connecting the known to the unimaginable, it is time to face one of the most invisible yet relentless enemies: cosmic radiation. In this deep space, where it seems there is nothing, there is something that never rests. An energy traveling through the universe at unbearable speeds, passing through. For in contemplating the brutality with which the universe penetrates us, we also discover what we are truly made of. And you? What are you made of? Your body is a miracle of adaptation, the result of billions of years of evolution, finely tuned to the exact conditions of a specific planet orbiting a specific star in a tiny corner of a specific galaxy. You breathe a perfectly calibrated mix of gases. Your cells operate within a narrow temperature range. Your blood flows at the right pressure. Your DNA repairs itself with millimetric precision, and your senses perceive only a fraction of the electromagnetic spectrum. But all of that, everything you are, depends on staying within the galaxy's protection. Human biology is not built for cosmic exposure, not even for near space. Without protection, you would die in seconds. Even with it, your body deteriorates, muscles atrophy, bones lose density, the heart weakens. And all this happens in space stations a few hundred kilometers from Earth. Now imagine being outside the galactic halo, far from any star, floating in an environment where temperatures approach absolute zero. Radiation is constant, and the absolute void looms like an unblinking shadow. And there is something even more unsettling. Not just the cold, not just the radiation, but isolation. At the galaxy's edge, you are already at the margins of interaction, but outside it, you are in a domain where life, as we know it, has left no trace, where there are no cycles, no day or night, no seasons, no magnetosphere, no oxygen, no liquid water, none of the elements evolution has considered essential for eons. There, you would be an experiment, a fragment of life artificially maintained in an environment that does not want you, does not need you, does not even know you exist. We might then ask, is it possible to redesign the human body to survive such an environment? Could we become something else? Science has already begun exploring this idea. Genetic engineering, genome editing, modification of radiation-resistant proteins, and the use of biocompatible compounds that do not degrade in the vacuum of space. Some propose adapting genes from extremophile organisms, bacteria that thrive in volcanoes, nuclear reactors, or acidic lakes. If they can survive, why can't we? Others go further. They talk about synthetic bodies, replacing tissues with artificial systems, or transferring consciousness into inorganic structures capable of withstanding extreme conditions. What if we abandoned the very concept of the human body to become modular, reconfigurable entities designed for environments where carbon-based life is no longer viable? And yet, there's one thing we cannot forget: time. Even if we created a body capable of withstanding radiation, cold, or the void, could it withstand time? Because a journey beyond the galactic halo is not measured in days or centuries. It could last millions of years, even at relativistic speeds. The time between galaxies is a wall of light years. So, what form of existence could remain active, conscious, and persistent for so long? Can anything human endure eternity? Here, physics and philosophy intersect. Perhaps it's not just about adapting biology. It might be about reimagining consciousness. If the body cannot cross, maybe the mind can. We could transfer our essence, thoughts, and memories to another medium. And instead of merely surviving, we might evolve in a different direction. Perhaps the question isn't, can human biology endure? But rather, how much of our humanity are we willing to leave behind to continue existing? Life until now has been biological. But was that a condition or simply a starting point? To inhabit the outer galaxy, we must stop thinking like tenants of planet Earth. We need to imagine new forms of being, bodies that need no oxygen, light, or temperature, minds that can process millennia of darkness without breaking, consciousnesses that don't rely on neurons or pupils. Beyond the galactic halo, there is no room for nostalgia. Everything must be reinvented, including yourself. When we think of planets, our minds instinctively default to the solar model. Bodies orbiting a star, trapped by gravity, bathed in light, sculpted by heat. But that comforting, structured image is only one version, a fragment of the cosmic repertoire. Out there, beyond galactic order, exist rogue planets, starless, solitary, wandering worlds traveling through deep space without a light source, orbit, calendar, or destiny. You may ask, how did they get there? Shouldn't all planets be born around a star? Many are, but not all remain. Some are expelled from their systems by gravitational collisions, encounters with massive objects, or early formation catastrophes. They are like exiled children of their solar systems, expelled, condemned to wander. These planets are dark, silent, invisible to the naked eye, yet by no means non-existent. Astronomers believe they could even outnumber ordinary planets. In our galaxy, for every star, there could be up to 2 rogue planets. And if that is true within the Milky Way, how many could be drifting in intergalactic space? Imagine one of these worlds, a gas giant without a star floating in darkness, or a rocky Earth-sized planet with an active core generating internal heat. Its surface would be locked in perpetual night, but beneath the ice, oceans might exist, liquid water heated by geothermal activity. And in those oceans, perhaps life. Life, as we've learned from the most inhospitable corners of Earth, doesn't always need the sun. Deep in Earth's abyssal oceans, where sunlight never reaches, entire ecosystems survive on planetary heat powered by chemical, not solar, energy. Why couldn't the same happen on a rogue planet? Here, the idea becomes powerful. These worlds could be capsules, refuges, cosmic arcs crossing the void without relying on a star. They could have hosted civilizations that knew their sun would die, civilizations that transformed their entire planet into a vessel rather than fleeing in ships, a planetary, not nomadic civilization. Science has already detected several candidates for rogue planets, such as objects CFBD 204 and others. They are young, massive, and alone. They do not orbit any star. They move through space with nothing but darkness as company. Some even emit heat, allowing detection via infrared, but most remain invisible. And if this is happening in our galaxy, what might be happening out there, beyond it? Outside the galactic halo, in the regions between galaxies, there could be millions of such solitary worlds traveling along unmapped routes, undetected, unimaginable, each with its own secrets. Some cold and dead, others hot and turbulent, some entirely empty, others perhaps harboring subterranean oceans with microbial life, or something more. Could humanity find refuge on a rogue planet? Could we build a self-sustaining dome and traverse the dark eras between galaxies? Perhaps not today, perhaps not tomorrow, but if we stop thinking in terms of stars and start thinking in terms of self-sustaining autonomous systems, then yes. These planets do not depend on the sun. They are independent, free, isolated, and therefore resilient. They need no calendar, know no day or night, obey no orbit. They simply move forward, and in an expanding universe, that is almost an act of rebellion. Perhaps one day, humanity itself must become like this. A being without a star, without a fixed direction, yet with an inner fire that still burns, sustaining life and remembering what it means to exist. Being a rogue planet does not mean being lost. It means independence. And in a universe where everything disperses, that may be the closest thing to freedom. Intrepid friends, dreamers of distant horizons, if throughout this cosmic journey we have questioned the nature of time and our ability to manipulate it, now we face a question as monumental as the vastness of space itself. Could we, as a species, one day transcend the limits of our own galaxy? Is intergalactic travel an impossible dream confined to science fiction, or a frontier humanity, with its relentless ingenuity, is destined to cross? Prepare yourselves, because we are about to confront the abysses of distance and the titans of physics that separate us from the stars beyond our home. Consider this. Our own galaxy, the Milky Way, is a majestic spiral of hundreds of billions of stars. Traveling from one end to the other at the speed of light would take roughly 100,000 years. 100,000 years, a span that dwarfs recorded human history. And that is only to cross our own galaxy. Now look outward, toward that faint mist in the night sky, known as the Andromeda Galaxy, our closest neighbor. It lies about 2.5 million light-years away. 2.5 million years traveling at the universe's maximum speed to reach it. The immensity of these distances is overwhelming, paralyzing the mind. Our brains, accustomed to kilometers and miles, struggle to comprehend scales measured by the time it takes light to travel. The fundamental barrier, the great cosmic wall before us, is the speed of light. According to Einstein's special relativity, nothing with mass can reach or exceed light speed. As an object with mass accelerates toward this cosmic limit, roughly 300,000 kilometers per second in a vacuum, its mass increases infinitely, and the energy required to accelerate it becomes infinite. It is a fundamental prohibition inscribed in the fabric of space-time. If a journey to Andromeda at light speed would take 2.5 million years, how long would it take at the speeds our current spacecraft can reach? The answer: millions of years, countless lifetimes of a star, far more than any civilization, no matter how advanced, could conceive for a single mission. So are we doomed to remain forever confined within the Milky Way, or are there theoretical loopholes? Solutions that, though fantastical today, could one day be the key to crossing galactic boundaries. This is where space-time manipulation comes into play. If we cannot move through space at light speed, perhaps we can make space itself move around us. We have discussed the Alcubierre drive, or warp drive. a theoretical solution in general relativity. This concept proposes creating a bubble of space-time around a ship. In front of the ship, space-time contracts. Behind it, it expands. The ship within the bubble remains stationary in its local frame of reference, but the bubble slides through the universe at effective speeds faster than light. It is like a surfer being carried by a wave. The surfer does not move faster than the wave, but the wave transports them at incredible speed. As you know, the viability of an Alcubierre drive depends on the existence of exotic matter with negative energy, a hypothetical substance that so far exists only in equations and infinitesimal amounts in quantum experiments. The amount of negative energy needed for an intergalactic journey via a warp drive is so immense, comparable to the energy of entire stars, that its construction seems a nearly insurmountable technological challenge. Yet the mere existence of this mathematical solution gives hope. It shows that the laws of physics permit the idea, even if we do not yet know how to implement it. Another, even more speculative possibility is wormholes. These theoretical structures, like tunnels connecting two distant points in space-time, could offer shortcuts that drastically reduce intergalactic distances. Instead of traveling 2.5 million light-years to Andromeda, theoretically we could pass through a wormhole and emerge on the other side in an instant. Yet again, constructing and stabilizing a traversable wormhole would require exotic matter and manipulation of gravity at an unimaginable scale. Beyond these ideas, what other paths could we explore? Generation ships, a more conventional alternative, but one that challenges our longevity, is the concept of generational ships. These are massive, self-sustaining space arcs capable of housing thousands or millions of people over centuries or millennia. Multiple generations would be born, live, and die aboard, hoping that their descendants would ultimately reach a new galaxy. Hibernation or cryogenics. If human life could be suspended for long periods through hibernation or cryogenic preservation, journeys spanning thousands or millions of light years could become conceivable for a single individual, reducing the subjective travel time to a few decades or years of conscious experience. However, the complexities of cryopreserving and reviving complex organisms remain largely unknown. Autonomous travel. Before sending humans, the first intergalactic explorations are likely to be carried out by self-aware robotic probes. These ships, perhaps with advanced AI, could endure millions of years of travel, collecting data and preparing the ground for eventual biological life arrival. Intergalactic travel is not just a technological challenge, it is existential. It forces us to confront our own finitude and the vastness of the universe. It pushes us to ask, what does it mean to be a cosmic species? What sacrifices are we willing to make? What generations would live and die solely so that their descendants could reach a new home? Ultimately, the question of whether we can reach galaxies beyond our own is not only one of engineering or physics. It is a question of our species' will, our ability to dream on a scale that transcends individual life and even the life of an entire civilization. We have the drive and resilience to embark on odysseys lasting millennia. Galactic frontiers call to us, but the path is fraught with monumental challenges. Yet humanity's story is one of surpassing limits. From the first human who gazed at the stars to the scientists designing warp drives on paper today, the thirst for exploration has driven our evolution. Traveling beyond our galaxy is not just a destination, it is a transformation of what it means to be human. But what awaits us in that vast darkness? What gravitational secrets, what unsuspected forms of life lie in the void between galaxies? Friends of gravitational mystery, explorers of invisible forces. If our understanding of gravity has been forged in the familiarity of planets and stars with their tangible, predictable attraction, what happens to this fundamental force when we venture beyond a galaxy's confines? In the vast, icy intergalactic voids, Where stars are rare and visible matter dissolves into whispers, gravity does not vanish. It transforms. It reveals a more enigmatic face, one that dominates the destiny of the universe on cosmic scales. Dark gravity. Think of gravity as we know it, the force that keeps you grounded, makes apples fall. Moons orbit planets, and planets orbit stars. It groups visible matter into the majestic structures we call galaxies. It is the architect of stars and planetary systems, yet on larger scales, the picture becomes far more complex. Galaxies are not randomly distributed. They form cosmic webs, vast filaments of matter interlaced with enormous voids. To form and maintain these structures, far more gravity is needed than ordinary matter can provide. Enter the cosmos' great phantom, dark matter. It is not matter in the traditional sense. It does not emit, absorb, or reflect light. It is invisible. We know it exists through its gravitational effects. Astronomers discovered that stars and galaxies rotate so fast they should fly off into space, or that galaxy clusters are far more massive than their visible light suggests. The only coherent explanation is the presence of a vast amount of invisible matter exerting gravitational force. Dark matter constitutes roughly 27% of the universe's total mass energy, over 5 times the amount of ordinary matter. Beyond galaxies in intergalactic space, ordinary matter's influence drops drastically, but dark matter is not confined. It forms an immense, invisible halo that extends far beyond. Fascinatingly, dark matter creates a cosmic network permeating the space between galaxies, acting as an invisible scaffold upon which the large-scale structures of the universe form and coalesce. The galaxy filaments, massive clusters, all held and orchestrated by the omnipresent, though invisible, gravity of dark matter. Imagine the universe as a gigantic spider web. Galaxies are like sparkling dewdrops at the nodes, but the web itself, the majority of its mass, is invisible dark matter. In intergalactic space, gravity is not just the pull of a nearby star. It is the subtle, persistent influence of this dark matter network surrounding us. If you were stranded in the vast void between 2 galaxies, you would feel the gravity of those galaxies, yes, but you would also feel the pull of dark matter filaments stretching across the darkness, guiding galactic flows, creating vast cosmic voids where almost nothing exists. The story grows even more enigmatic with the second great phantom of the cosmos. Dark energy, discovered in the late 1990s when astronomers observed the universe's expansion accelerating. Dark energy is even more mysterious. It is neither matter nor an attractive force. It is a kind of energy inherent to space itself, exerting a repulsive pressure, pushing space-time and accelerating its expansion. It constitutes roughly 68% of the universe's total mass energy. In intergalactic voids, where visible and dark matter thin out, dark energy dominates. It is the force pushing galaxies ever farther apart at an accelerating rate. In deep space, the gravity we experience is not merely the residual pull of distant galaxies, but the inexorable action of this dark energy, stretching space-time itself on a monumental scale. Thus, intergalactic gravity is not the absence of gravity. It is the interplay of 2 of the universe's most dominant and enigmatic entities. Dark matter, which groups matter on cosmic scales, and dark energy, which accelerates the universe's expansion, driving it toward extreme emptiness and cold. If we were to travel beyond our galaxy, we would encounter a gravitational field dominated not by stars or planets, but by invisible halos of dark matter and the expansive pressure of dark energy. This has profound implications for any intergalactic journey. Ships would have to contend not only with astronomical distances, but also with the invisible gravitational architecture of the cosmic web. Dark matter could provide gravitational highways along filaments or regions of emptiness where attraction is minimal. Dark energy, on the other hand, would act as a constant resisting force, pushing our ship beyond its limits, accelerating our separation from all that is known. The dark gravity of the cosmos is a testament to how little we truly understand about 95% of the universe. It is the background music orchestrating the dance of galaxies, the invisible force shaping the fate of the cosmos. Understanding it is not just a scientific challenge. It is an invitation to expand our minds beyond the observable, to recognize that most of reality operates under veils we are only beginning to glimpse. And in that intergalactic silence, where the light of galaxies becomes barely a whisper, gravity does not vanish. It whispers its deepest secrets through forms of matter and energy that still elude us. A journey to these edges would not only be a physical challenge, but an immersion into the true nature of the force that binds and unbinds the universe. But what if, in that darkness, beyond the light of suns, a form of life could emerge that defies all our conceptions? Friends of the improbable, dreamers of alien biology, if our existence on Earth is inextricably tied to the benevolence of our sun, to its light that nourishes plants and warms our oceans, then this dependence is a universal law. When we look toward the vast and frigid intergalactic space, a place where stars are rare and darkness is the norm, a question arises that brushes both poetry and terror. Could there exist a form of life adapted to perpetual darkness, a biology that does not rely on the glow of a sun? Prepare yourselves, because we are about to speculate on the most radical possibilities of cosmic life. Our concept of life is understandably centered on carbon and water, with light energy as its primary source. On Earth, sunlight-driven photosynthesis is the foundation of nearly every food chain. Yet even here, life has demonstrated a staggering ability to adapt to extreme environments, often without relying on sunlight. Think of the depths of our oceans, along the oceanic ridges where sunlight never penetrates. There, in a world of crushing pressure and eternal darkness, entire ecosystems thrive. Their source of energy is not light, but chemosynthesis. Specialized bacteria metabolize chemical compounds released by hydrothermal vents, such as hydrogen sulfide, methane, or iron. These bacteria form the base of a food chain supporting giant tube worms, blind crabs, and bizarre creatures. Life has found a way to subsist in total darkness, drawing energy from the very bowels of the Earth. If life can flourish without sunlight on Earth, what does that tell us about deep space? In intergalactic abysses, where galaxies are islands of light in an ocean of darkness, the energy from a distant sun would be insignificant. For life to exist there, it would require alternative energy sources and perhaps fundamentally different chemistry. Here are some of the boldest hypotheses. Cosmic chemosynthesis. Just like in the ocean depths, life in intergalactic space could extract energy from chemical reactions. Where would the reactants come from? They could originate from the radioactive decay of heavy elements in the cores of rogue planets, those ejected from their star systems or galaxies, or from interactions with magnetic fields and high-energy particles, which, though scarce, are present in the intergalactic medium. A rogue planet with a geologically active core could offer a niche for chemosynthetic life, heated by its internal geothermal energy. Life based on ice and ammonia. Water, though an excellent solvent, freezes at low temperatures. However, in deep space, where temperatures approach absolute zero, negative 273 degrees Celsius, other liquids could serve as solvents. Methane or ammonia, which remain liquid at much lower temperatures, could be the basis for exotic biochemistry. Life under such conditions would operate at an incredibly slow pace, almost suspended. Dark life and dark matter. This is an even more speculative concept. If dark matter constitutes most of the universe and we have yet to detect it directly, could it interact in subtle ways that allow for life based on it? It borders on fantasy, but if dark matter has unknown properties, who's to say it couldn't be the basis of a radically different biology? A biology existing beyond our perception, a universe of dark life invisible to us. Energy extraction from fields and radiation. Intergalactic space, though vast, is not entirely empty. It contains a thin intergalactic medium, cosmic magnetic fields, and the cosmic microwave background, the residual glow of the Big Bang. Exotic life forms could have evolved to extract energy from these fields or from ultra-dilute radiation. A creature acting as a biological antenna or cosmic capacitor, harvesting energy from quantum fluctuations of the vacuum, could be a possibility in a universe of unimaginable adaptations. Non-carbon-based life. Our life is carbon-based for its versatility in forming complex bonds. But elements like silicon, which share similar chemical properties, could form the basis of alternative biochemistry under extreme temperatures and pressures. Silicon life, theorized by some scientists, could operate in far harsher environments than carbon-based life. The implications of a sunless biology are monumental. It would force us to redefine what we understand as life and expand our search beyond the habitable zones around stars. The vast oceans of rogue planets, the cold of molecular clouds, even the intergalactic void itself could host forms of existence barely imaginable. A civilization born in darkness, without the constant reference of a sun, would conceive of time and space differently. Its biology and technology would be inherently distinct, adapted to energy scarcity and the vast silence. Perhaps its evolution would lead it to a comprehension of the universe beyond our solar-centric perception. The search for life without light is not just a search for aliens. It is a search for ourselves, for the versatility of existence in the cosmos. It confronts our own biological biases, the belief that life must resemble ours to be life. The cosmos challenges us to expand our definition of the possible, to imagine ecosystems where energy comes not from stellar heat, but from particle whispers, the stillness of chemical reactions, or even the dark fabric of the universe itself. And in that darkness, we might find proof that life is not a rare miracle, but an inherent property of the cosmos, ready to flourish in the most unexpected conditions. If life can exist without light, who else might be out there, beyond our radar, in the vast expanses we are only beginning to explore? Absolutely. We have unraveled the astonishing possibility of biology flourishing in cosmic darkness, beyond the light of suns. But if life can adapt to such extremes, an inevitable question arises with urgency, resonating through intergalactic abysses. Who could already be out there? Yes, instead of seeking habitable planets orbiting stars, we should seek civilizations that have transcended the need for a fixed home. Cosmic nomads already populating the great beyond. Friends of the hidden, seekers of intelligence in the shadows. If life on Earth teaches us that evolution anchors us to a planet and a star, the vastness of the universe and the daring of physics invite a grander vision. What if advanced civilizations were not merely world dwellers, but navigators, entities capable of transcending the need for a fixed home, becoming eternal wanderers of the galaxy or even intergalactic space? We are about to consider the true pioneers of the cosmos. Those who might already be out there in the great beyond, beyond the reach of our detection. Our search for extraterrestrial life has been predominantly focused on habitable zones around stars, those golden belts where liquid water can exist on a planet's surface. We have listened intently to the whispers of exoplanets, dreaming of finding a second Earth. But this perspective, while logical for our biology, is intrinsically limited by our experience. Imagine a civilization that has reached a technological and energy level, allowing it to break free from its stellar cradle. Perhaps they have mastered their star's energy entirely, building a Dyson sphere, a hypothetical megastructure encapsulating a star to capture nearly all its energy. Once they extract all potential from their sun, or if their star reaches the end of its life, why remain tied to a single system? Such a civilization could develop technology to dismantle its own star system or parts of its planet, and convert it into a vast fleet of space habitats, mobile colonies capable of crossing interstellar expanses. These would be the stellar nomad civilizations, planet-sized ships or fleets of artificial worlds moving between stars, exploiting resources from each system before continuing onward. Their home would not be a planet, but the ship itself, a closed ecosystem providing all necessities for eons. They could already be crossing the vast spaces between stars in our own galaxy, imperceptible to telescopes searching for stellar flares or planetary biosignatures. And their audacity could extend further. If they mastered interstellar travel, why not intergalactic travel? Once a civilization has built megastructures capable of sustaining millions for millennia, jumping from one stellar system to another becomes a prelude to jumping to an entire galaxy. Vast distances, which seem insurmountable to us, could be mere engineering challenges for them. Consider then intergalactic nomadic civilizations, entire fleets of habitats powered by zero-point energy or theoretical warp drives, crossing the dark void between galaxies. They could be colonizing rogue planets, solitary worlds drifting freely through intergalactic space, stripped of their stars. These planets, though frigid, might have hot cores or underground volcanoes, providing geothermal energy to sustain life. A civilization living on a rogue planet has no sun to track. It moves with its world through the vastness, a form of existence that defies our conceptions. And if the solution to the Fermi paradox is not that life is rare or civilizations go extinct, but that we are simply looking in the wrong place? We have heard silence because we search in fixed homes in cities of stars, when perhaps the most advanced civilizations are the nomads traveling intergalactic highways. Their massive structures could be undetectable if they emit no obvious signals or are designed for discretion, leveraging the vast darkness of space for camouflage. Consider the purpose of such nomadic existence: the pursuit of infinite resources, escaping the death of their stars, an insatiable curiosity to explore every corner of the multiverse, or even fleeing some cosmic catastrophe. A civilization that has existed for millions or billions of years could have developed a collective consciousness, a mode of being transcending the need for a planetary home, turning the universe itself into its domain. The existence of these nomads would raise profound questions about our own future. If we achieve interstellar travel, would we too become nomads, leaving our homeworld to join the great cosmic migration? Would that be the next inevitable step in a species' evolution, the breaking of gravitational ties to a single sun? The mere thought that such civilizations could already be out there, silently sliding their artificial worlds through intergalactic darkness, is both humbling and exhilarating. It forces us to expand our imagination beyond the confines of solar systems and consider that life and intelligence could manifest in ways defying our deepest expectations. The universe is not merely a collection of islands of stars, it is a vast ocean, and perhaps the largest, most advanced creatures are already navigating its invisible depths to our eyes because we have been searching along the coasts. Their existence reminds us that the edges of the universe are not inert voids, but a stage for a cosmic dance of unimaginable proportions. But in that outer space, beyond the light, what other strange properties of the cosmos await? Absolutely. We have speculated on the existence of nomadic civilizations in intergalactic darkness. Yet for any life, or matter itself, to persist in those abysses, it must face one of the universe's most extreme and fundamental challenges: cold. A cold so intense it skirts the limits of possibility. A thermal abyss that freezes not only matter, but perhaps even alters the perception of time. Prepare yourselves, observers, because we are about to plunge into the cold abyss. the realm of absolute zero between galaxies, and its profound implications for existence as we know it. Friends of the cosmic chill, travelers to the edges of thermodynamics, if our home, Earth, basks in the warmth of its sun and galaxies are temperate islands in the vastness, there exists a realm between them, an abyss of overwhelming cold that defies the very notion of motion. We speak of intergalactic space, a place approaching with disturbing proximity, absolute zero. Prepare to explore the consequences of this cosmic freezing and how it affects not only matter, but time and perhaps consciousness itself. Absolute zero is the theoretical lowest possible temperature, the point at which thermal motion of particles ceases entirely, defined as 0 Kelvin or minus 273.15 degrees Celsius. In Earth laboratories, we can approach this limit, cooling atoms to tiny fractions above absolute zero, where they exhibit strange quantum behaviors. But in intergalactic space, nature itself creates an environment nearing this threshold almost perfectly. Consider this. In deep space, far from the influence of any star or significant heat source, there are virtually no particles with which energy can interact and warm. Galaxies, with their billions of suns, are small furnaces radiating heat into the surrounding vacuum, but as we move away from them, that heat dissipates exponentially. Space cools to roughly 2.7 Kelvin. That incredibly low temperature is not a perfect vacuum. It is the residual echo of the Big Bang, known as the cosmic microwave background, the oldest light in the universe, the residual glow of an era when the cosmos was a hot, dense plasma. But for our purposes of life and movement, 2.7 Kelvin is, indeed, a freezing abyss. What does this extreme cold mean for matter? At these temperatures, atomic motion slows almost to a halt. Chemical reactions become incredibly sluggish. Matter, as we know it, becomes inert, fragile, and with minimal kinetic energy. If a spaceship traveled to these regions without massive active heating, its components would freeze instantly, becoming brittle as glass. Any liquid would solidify, and gases would condense. Intergalactic space is literally a cosmic freezer in time. Here's where it gets even more interesting. Though cold does not directly stop time, unlike extreme velocity or gravity, it drastically slows the processes that allow us to perceive it. Our perception of time is linked to change, movement, and the sequence of events. If chemical reactions slow, if the metabolism of a hypothetical creature reduces to infinitesimal drags, then its subjective experience of time also slows. Biological life operating at these extreme temperatures could perceive a second as a millennium as a blink of an eye, a form of perceived temporal travel for consciousness. If a biological consciousness depends on neural activity, and neural activity depends on chemical and electrical reactions, then consciousness itself would slow or even halt at absolute zero. Computers, if they existed at these temperatures, would operate at infinitesimal speeds. This raises the question, could there exist a form of consciousness that does not rely on particle movement or that operates on a timescale so vast that our notions of thought or feeling become irrelevant? Perhaps a mind existing at absolute zero would experience eons as mere instants, living a compressed eternity. Yet, the cold of intergalactic space might also offer advantages for future civilizations, for generation ships, or for cryopreservation. Temperatures close to absolute zero would be ideal for preserving matter and life over eons. A ship could shut down its active systems, and if its materials could withstand extreme cold, it could drift through deep space in a state of near-perfect suspended animation, conserving its resources and extending the lifespan of its components for billions of years until it approached its destination. The cold abyss also serves as a reminder that the universe is inherently hostile to life as we know it. Life is a low-entropy phenomenon, an oasis of order in a cosmos that trends toward disorder and cold. Intergalactic space is the realm of near maximal entropy, where energy has dispersed and matter is in its most inert state. Yet, even in this immense cold, secrets may still lie hidden. Quantum fluctuations in the vacuum, even at Kelvin levels, never cease. Quantum fields continue to vibrate. Could life, or an exotic form of existence, find a way to extract energy from these fluctuations or from the weak streams of particles still passing through the void? The human mind, in its infinite capacity for speculation, can conceive that even in the absolute stillness of zero, the seed of existence might find a niche. Absolute zero between galaxies is not just a temperature. It is a backdrop for the universe's ultimate fate, a silent echo of thermodynamics. It reminds us of the fragility of our existence, bound to the warmth of a star and of the vastness of the conditions awaiting us beyond our home, yet at the same time challenges us to imagine forms of life and consciousness that transcend our limitations, adapting to the stillness, slowness, and cold of a universe expanding into its eternal winter. And in that icy silence, even deeper questions arise. Is intergalactic space truly empty, or do its silences conceal a universe of invisible quantum activity? Absolutely. We have descended into the depths of the cold abyss between galaxies, a place where visible matter and energy seem to vanish into frozen stillness. But now, it is crucial to challenge our most deeply rooted intuition, the idea that the void is, in fact, empty. Prepare yourselves, observers, because we are about to unveil that intergalactic space, even in its darkest and coldest extremes, is not mere nothingness, but a boiling cauldron of invisible activity, a vibrant tapestry of quantum fields whispering the deepest secrets of existence. Friends of the invisible mystery, divers into the essence of reality, if the intergalactic vastness seems like an abyss of nothingness, a blank canvas where galaxies are mere ink dots, our perception is fundamentally mistaken. Modern physics, specifically quantum mechanics, reveals an astonishing truth. The vacuum, that space which seems devoid of everything, is actually an ocean of invisible energy, a boiling soup of subatomic activity. Prepare yourselves, because we are about to dive into the pulsating heart of the quantum vacuum between galaxies. For centuries, the vacuum was conceived as the absence of everything, a space without air, without particles, without light, simply nothing. But in the early 20th century, the advent of quantum mechanics and quantum field theory radically changed this view. It was discovered that space, even the emptiest we can imagine, is not truly empty. It is full, saturated, infused with quantum fields. Think of it as a vast ocean. We do not see the water individually, but we know it is there. The universe is filled with fields like the electromagnetic field, the electron field, the quark field, the Higgs field. Each type of particle is an excitation, a vibration, a ripple in its corresponding field. When we see an electron, we are seeing a vibration in the electron field. When we see a photon, a particle of light, we are seeing a vibration in the electromagnetic field. The key to the seemingly empty vacuum lies in Heisenberg's uncertainty principle. This fundamental quantum principle states that certain pairs of a particle's properties, such as position and momentum or energy and lifetime, cannot be known with perfect precision simultaneously. This means that there can never be a perfectly empty space of energy, not even for an instant. If a space had exactly zero energy, we would know its energy with perfect precision, violating the uncertainty principle. To avoid this violation, the quantum vacuum is constantly boiling with what we call quantum fluctuations. These fluctuations are spontaneous appearances and disappearances of particle-antiparticle pairs known as virtual particles. These particles emerge from the inherent energy of the vacuum. They exist for an infinitesimally small instant and then annihilate each other, returning energy to the vacuum. It is like a bubbling foam that constantly creates and destroys itself at the most fundamental level of reality. They are ghosts that vanish before we can detect them directly, but their existence has measurable consequences. The evidence for this full vacuum is not mere conjecture. It is a proven reality. The Casimir effect, for example, is a direct manifestation of vacuum fluctuations. If you place two metal plates very close together in a vacuum, you will notice a small force pushing them. This force arises because the number of virtual particles between the plates is less than the number of virtual particles outside, due to the wavelengths that can exist in such confined space. The difference in pressure from these virtual particles pushes the plates together. This is not just a theory. It has been measured experimentally with remarkable precision. Now, apply this understanding to intergalactic space, that vast abyss that seems so silent and desolate. Even there, far from stars, planets, or visible matter, the vacuum is not nothing. It is a sea of quantum fields, a bubbling cauldron of virtual particles, appearing and disappearing in an eternal dance. The absence of ordinary matter does not mean the absence of fundamental activity. The implications of this are profound. Vacuum energy. The fluctuations of the vacuum imply that space has inherent energy, a zero-point energy. This energy, though in principle immense, is extremely difficult to harness in any useful way. Yet some theorists speculate on its potential as an almost limitless source for future civilizations. Imagine ships drawing their power from the very nothingness of space. The quantum vacuum is the glue that binds all particles and forces. It is the medium through which interactions propagate. Even in the most remote intergalactic space, the laws of physics are mediated by these underlying fields. It is the matrix that permeates the entire universe. Some suggest that in the far future, in a cold and empty universe, ordinary matter could disintegrate. If that happens, the only things left would be these fundamental quantum fields and the energy of the vacuum. The physics of the distant future, the physics of the dark era, might be the physics of the quantum vacuum, and perhaps new forms of existence or interaction could arise there. There is no true nothingness. This is the most philosophical revelation. The vacuum that once represented total absence becomes the source of all existence. It is the primordial ocean from which everything emerges. The universe is never truly empty. It is always filled with potential, with possibilities, with the dance of creation and annihilation at the most fundamental level. Intergalactic space, that abyss of cold and apparent inactivity, is in fact a cosmic theater where the play of quantum mechanics unfolds every instant. It is where visible matter and energy have diluted, but quantum fields and virtual particles continue their invisible dance. If one day we travel to these edges, we will not encounter absolute emptiness, but a vibrant, pulsating reality. A hidden canvas of energy that is the true essence of the universe. Understanding this vacuum brings us one step closer to comprehending not just the cosmos, but the very soul of matter at the edges of existence itself. The vacuum between galaxies is not an inert nothingness, but a bubbling cauldron of quantum fields. But now, we must take this understanding further, diving into the depths of matter itself and asking, what happens to the soul of particles, to time, and to the forces governing them when we venture to the remotest corners of the universe, beyond the light of galaxies and the presence of any known civilization? Prepare yourselves, observers, because we are about to contemplate the ultimate fate of matter, time and the very essence of reality at the edge of the cosmos. A place where the laws of physics reveal themselves in their purest and most enigmatic form. Everything around us is composed of fundamental particles, electrons, quarks that form protons and neutrons, photons, particles of light, and the mysterious neutrinos. These particles are the building blocks of the universe. In our local environment, in our galaxy, These particles interact constantly, forming atoms, molecules, stars, and living beings. They are the language through which the universe communicates and organizes itself. But as we venture toward the edges of the observable universe, the density of visible matter drops drastically. Galaxies become scarcer, and light grows fainter. In the vast void between galaxy superclusters, the average distance between two atoms could span kilometers. The universe becomes incredibly diluted and lonely. What does this mean for the particles themselves? In this environment of extreme solitude, interactions between particles become incredibly rare. A proton might pass billions of years without colliding with another. Photons can travel eons without being absorbed. In a sense, particles become purer, less disturbed by the interactions and collisions that define their behavior in dense environments. They are like solitary travelers in an endless ocean. But beyond solitude, what happens to the very identity of these particles? Particles have fundamental properties: mass, charge, spin. Mass, as we know, is intrinsically linked to the Higgs field. This omnipresent field permeates the universe and gives mass to fundamental particles. An electron interacts with the Higgs field, and in doing so acquires mass as if moving through cosmic molasses. If the Higgs field weakened at the edge of the universe, it could change particle masses. The Higgs field is considered constant throughout the universe, a fundamental property of reality itself. But its existence reminds us that even mass, a property we take for granted, arises from interaction with an invisible field that permeates space and time. What happens to time at the edges of the universe? In these regions, gravitational forces are minimal. The influence of stellar and galactic masses is diluted almost to nothing. Gravitational time dilation becomes negligible. However, the expansion of the universe, driven by dark energy, becomes the dominant factor. Clocks would still tick, but the experience of the arrow of time might intensify as galaxies move away from one another at accelerating speeds, and the universe becomes progressively colder, darker, and emptier. Time at the edge becomes the timer of cosmic dissolution. Yet there is an even deeper consideration. If quantum vacuum fluctuations are the bubbling foam of reality, what about those fluctuations at the edge? They persist because they are inherent to space-time itself. The life of virtual particles continues its ephemeral dance even in the emptiest vacuum. This means that even when visible matter is exhausted, the universe at its most fundamental level remains a cauldron of activity, an unceasing source of creation and annihilation. The idea of the soul of matter at the edge of the universe invites philosophical reflection. There, matter approaches its most diluted, purest state. It is nearly free of the interactions that define it in complex systems such as stars or planets. One could say that matter reveals its true essence, its fundamental identity, without environmental perturbations. Each proton, electron, and photon becomes a solitary witness of the vastness, carrying the properties conferred upon it at the dawn of the cosmos. And what of the destiny of these particles in an unimaginably distant future? As the universe expands and cools, atoms may disintegrate. Protons may decay if proton decay theory is correct, and black holes will evaporate through Hawking radiation. In the end, the only remnants would be scattered elementary particles, extremely low-energy photons, and perhaps ghosts of dark matter. And dark energy, the soul of matter at the edge of the universe. This is a vision of our cosmic destiny, the final dissolution of complexity into fundamental simplicity. This journey to the edge of the universe is not just a physical extrapolation. It is a meditation on solitude, vastness, and the resilience of existence. It shows us that even in the most extreme conditions, the fundamental identity of matter persists. Time continues its advance, and quantum fields keep vibrating. It forces us to confront the abyss and ask what it truly means to be part of a universe that expands, cools, and, at its edges, reveals the pure essence of what is. And contemplating these edges brings an even more fundamental question. What separates one galaxy from another? It is not merely distance, it is a rupture of existence itself. Look at the night sky and you see points of light. Some are stars of our own galaxy, the Milky Way. Others, barely perceptible, are the light of distant galaxies, vast universes in their own right. Intuition tells us that what separates them is simply immense distance, an abyss of empty space. Yet this perception, while fundamental, is a poetic simplification that hides a much deeper, more astonishing truth. The separation between galaxies is not just a matter of kilometers or light years. It is an energetic rupture, an informational fracture, and a gravitational discontinuity that redefines the very concept of the vacuum. Consider distance and time. The Andromeda Galaxy, our closest neighbor, is 2.5 million light-years away. This means the light we see from Andromeda left it 2.5 million years ago, when Earth was still in its early stages of human development. This vastness of intergalactic space is, in itself, a form of temporal separation. When we look at another galaxy, we see not its present, but its distant past. We are intrinsically separated by eons of light travel, a barrier our current technology can only dream of crossing. Beyond passive distance, there is an energetic rupture. A galaxy is a colossal concentration of energy. Billions of stars radiate light and heat, creating an environment relatively warm compared to intergalactic space. Energetic processes, nuclear fusion, supernovae, all boil within galactic confines. Outside these islands, energy dilutes exponentially. A galaxy's glow fades into cosmic void, where temperatures approach absolute zero and matter density is near nothing. This is a fundamental energetic discontinuity. A civilization attempting to thrive in intergalactic space would require radically different energy sources, for the vast expanse outside is an energy desert compared to a galaxy's oasis. Then there is the informational rupture. Within a galaxy, information propagates relatively easily, at least on cosmic scales. A star's light can travel thousands of light-years to reach a planet. Radio waves from a civilization could traverse hundreds of light-years. There is informational connectivity, a flow of data, even if we are passive listeners. Between galaxies, however, the informational flood becomes an infinitesimal trickle. A radio signal from Andromeda, even if sufficiently powerful, would take 2.5 million years to reach us. Matter density is so low that interactions are rare. The ability to observe, communicate, or even conceive of another galaxy instantly is impossible. This gap is a barrier to real-time communication, a veil isolating us within our own cosmic information bubble. Perhaps the deepest is the gravitational rupture. A galaxy is not just a cluster of stars, it is a gravitationally bound system. The gravity of stars, dark matter, and its central supermassive black hole keeps all its components in a unified dance. It is an island of attractive gravity dominating its interior and shaping its boundaries. Beyond this gravitational influence, in intergalactic space, the pull of any specific galaxy diminishes drastically. What dominates, as we have explored, is the dark matter network and the repulsive pressure of dark energy, accelerating the universe's expansion. For an object traveling between galaxies, it is no longer in the stable orbit of a single source of gravity. It is at the mercy of far subtler forces and, ultimately, the accelerated expansion of space itself. Consider the fate of our galaxies. The Milky Way and Andromeda are on a collision course. In about 4.5 billion years, they will collide. But this collision is an anomaly, the result of both galaxies being gravitationally bound within our local group. Beyond our local group, galaxies are moving away from each other at ever-increasing speeds due to dark energy. The time will come when the most distant galaxies will move so fast that their light will never reach us. They will fade beyond our observable horizon, not because space is empty, but because the expansion of space is so rapid that their light stretches into invisibility, or never arrives at all. By then, they will be completely separated from us, not just by distance, but by the fabric of space-time itself. Thus, the separation between galaxies is a multifaceted manifestation of the universe's architecture. It is a temporal barrier, the light time it takes for photons to reach us. It is an energetic void, the absence of dominant sources of heat and light. It is an informational frontier, the impossibility of instantaneous communication or interaction. It is a gravitational rupture, the transition from a region dominated by attractive gravity to one dominated by the expansion of dark energy. What truly separates one galaxy from another is the very fabric of expanding space-time, held together only by the invisible threads of dark matter and ultimately pushed apart by omnipresent dark energy. This reminds us that we live in a vast and evolving universe where connections are not eternal and cosmic islands are destined to drift apart unless local gravitational forces hold them together. And in that cosmic isolation, in that immense separation, a deeper question arises. If matter and light dissolve, could consciousness, the intangible essence of our being, survive without a visible universe to observe it? Absolutely. We have unraveled the vast ruptures that define the space between galaxies, abysses of distance, energy, and information. But if we venture into a realm where light fades and matter dilutes into invisibility, a profound question emerges. Can consciousness, the mysterious fire burning within us, persist when there is no visible universe to observe, interact with, or define it? Prepare yourselves, observers, for we are about to enter the limits of perception and identity. A journey to the essence of mind beyond the physical cosmos, where reality itself might be a product of what we are capable of perceiving. Right now, in this very instant, you are experiencing reality through your senses. The light reaching your eyes, the sound caressing your ears, the texture beneath your fingers. Your consciousness is shaped and nourished by constant interaction with the visible universe around you. But what if we traveled so far that the visible universe vanished into impenetrable darkness? What happens to the mind when there are no twinkling stars, no shining galaxies, not even the slightest fluctuation of light to convey information? In that void of stimuli, in the great exterior where the cosmos becomes abstraction, could consciousness persist, or would it dissolve into nothingness along with sensory reality? This question takes us to the deepest intersection of physics, philosophy, and neuroscience. Most current scientific theories consider consciousness an emergent phenomenon of the brain, a product of complex neuronal activity. If the brain requires energy and stimuli to function, how could consciousness survive in an environment with no visible matter, no light, no heat, and not even the conditions to keep a biological or complex artificial brain operational? Consider the extreme conditions of intergalactic space. Temperatures near absolute zero, particle densities approaching nothingness, and distances so vast that any interaction would be unimaginably slow. In such an environment, a biological brain would freeze instantly and cease to function. A computer, no matter how advanced, would require a constant energy source and colossal thermal insulation to operate, and its capacity to process information would be limited by the speed of light and scarcity of external data. So, what possible scenarios could we speculate for the survival of consciousness in a universe without visible stimuli? Suspended or slowed consciousness. Just as matter slows near absolute zero, consciousness could theoretically enter a state of suspended animation or extreme slowdown. If a civilization could cryogenically preserve their minds or transfer them into a medium operating at ultra-low temperatures, the subjective perception of time could stretch so that eons pass as moments. Consciousness would not be active in our everyday sense, but it could preserve its identity and awaken in the distant future when stimuli return. It would be a form of survival, but not active existence in the void. Consciousness as a fundamental property. This is a far more radical and philosophical idea. What if consciousness is not merely a product of the brain, but a fundamental property of the universe, perhaps as basic as space, time, or energy? If consciousness exists beyond matter, a view known as panpsychism or dualism, then it would not require a visible universe to persist. It could float as a non-physical entity, a kind of cosmic soul, experiencing reality in ways beyond our sensory comprehension. In this scenario, the visible universe would be just one of many screens onto which consciousness projects itself. Universal scale consciousness. If consciousness unified or expanded beyond the individual, an advanced civilization might have merged its minds into a collective consciousness, a massive network spanning vast regions of space. If this network extended across galaxy clusters or even intergalactic regions, it could interact with quantum fields and dark matter in ways beyond our understanding. Its perception would not depend on light, but on subtle fluctuations of the vacuum, the gravitational web, and dark energy itself. A cosmic mind feeling the universe at its most fundamental scales, transcending the need for visible stimuli. Consciousness as an inner simulacrum. In a universe devoid of external stimuli, advanced consciousness might retreat entirely into an inner world. This could involve creating incredibly vivid reality simulations within their own minds, or vast quantum computers operating on microscopic levels. The reality they experience would come not from the outside, but from their internal creation. They could live in simulated universes as real as ours, without the need for an external visible cosmos. A form of self-containment, a retreat into the garden of the mind. Consciousness adapted to the void. If life can adapt to darkness without suns, as we saw in Chapter 9, could consciousness evolve to process information in radically different ways? A dark consciousness could perceive weak intergalactic magnetic fields, vacuum fluctuations, or even the subtle pull of dark matter as a form of sense. Its visible universe would not be light, but the invisible forces and fields that fill the apparent void. The question of consciousness surviving in a universe without visible stimuli is, at its core, a question about the nature of consciousness itself. Is it purely a physical phenomenon dependent on material and energetic support? Or is there a transcendent element that can exist beyond the limits of matter and light? It forces us to contemplate that our brain, in its current state, might be just one of many antennas consciousness could use to interact with reality. In the distant future, when stars have faded and the universe has expanded into cold darkness, will any spark of consciousness remain, a last mind observing nothingness? This reflection on consciousness in the void is not merely a philosophical exercise. It is an invitation to expand our understanding of what we are and what we might become. For if consciousness can survive without a visible universe, then our own identity, our soul, could be far more robust and fundamental than we ever imagined, transcending not only space and time, but matter and light. This profound meditation brings us to the heart of the loneliest and most mysterious objects in the cosmos: intergalactic black holes. You know black holes, those cosmic abysses where gravity is so intense that nothing, not even light, can escape. They are the devourers of stars, the invisible architects at the hearts of galaxies. But most black holes, we imagine, are tied to their galactic homes, orbiting the center or scattered among stars. Yet there is a class of these dark titans that roam the vast, frigid intergalactic space, solitary and silent, lost between galaxies. What are these massive objects, and what implications do they hold for travel and understanding of the universe beyond our galactic confines? Think about how a black hole might end up in intergalactic space. Gravitational ejection from galaxy collisions. In the frenzy of galactic mergers, supermassive black holes at their centers can interact violently. Complex gravitational dances can fling one or more of these colossi at speeds so high they escape the gravitational embrace of the newly merged galaxy. They become wandering black holes, gravitational ghosts traveling through intergalactic space at thousands of kilometers per second. Primordial black holes. Another, more speculative hypothesis is the existence of primordial black holes. These would have formed in the universe's first moments from density fluctuations in the primordial plasma, without needing a star to collapse. If they exist, some might have survived to this day, wandering through intergalactic space, from small asteroid-sized ones with the mass of a mountain to the largest remnants of dwarf galaxies. Dwarf galaxy remnants. The smallest and sparsest dwarf galaxies are most susceptible to being torn apart by larger galaxies. If a dwarf galaxy had a central black hole, it could survive the destruction of its host galaxy and continue its solitary journey. These intergalactic black holes are incredibly hard to detect. They emit no light, and being far from any star, they have no material to devour that would produce the bright X-ray jets that reveal their galactic cousins. We would only detect them through subtle gravitational effects, bending of light from distant stars, gravitational lensing, or gravitational dragging on other galaxies or gas clouds. They are the silent ghosts of the cosmos. What implications do these wandering black holes have for our understanding of the beyond? Theoretical bridges. Wormholes have been proposed as shortcuts through space-time. Theoretically, a black hole could be the mouth of a wormhole if the exotic matter required to keep it open could exist. If it were possible to stabilize and traverse one of these intergalactic black holes, they could become instant jump points to distant galaxies or even other universes. They would be the natural stargates of the cosmos, though their feasibility is purely speculative. Gravitational traps. For any ship or civilization traveling intergalactic space, a wandering black hole would be an invisible and catastrophic danger. Its immense gravity would pull any nearby object with unstoppable force. They would be cosmic traps, gravity wells that swallow anything approaching too closely without a trace. Intergalactic navigation would require incredibly precise gravitational maps and black hole detection technology far beyond our current capabilities. Environments for other physics. Near a black hole, the laws of physics stretch to their limits. Time dilates dramatically, space curves extremely. A civilization somehow safely orbiting a black hole, perhaps harnessing the energy released as matter falls into its accretion disk, would experience reality in radically different ways. Time would pass more slowly for them than for the rest of the universe, turning them into involuntary temporal travelers into the future. They could study singularity physics, quantum gravity, and perhaps uncover secrets of the universe inaccessible in less extreme environments. Natural laboratories for dark matter. Black holes, especially supermassive ones, are surrounded by halos of dark matter. Studying how dark matter interacts with black holes could offer clues about its nature. Intergalactic black holes, isolated from ordinary matter, could be ideal laboratories to study dark matter in its purest form without contamination from baryonic matter. The existence of intergalactic black holes reminds us that the void between galaxies is not as empty as it seems. It is populated by these silent giants, witnesses to past galactic collisions and potential architects of cosmic futures. They are dark beacons in the vastness, reminders that the universe is far stranger and more complex than our intuition allows us to comprehend. A journey to these frontiers would challenge not only our technology, but also our perception. It would force us to redefine our place in a cosmos where darkness and invisible gravity are the dominant forces. And contemplating these solitary abysses raises an even deeper question. Can a being observe from the outside without being affected by what it sees? Is it possible to maintain objectivity when venturing into the unknown beyond galactic structure? Right now, you are observers. You look, listen, feel, and your consciousness processes the information arriving from your environment. But your environment is Earth, a planet in a star system, in the arm of a galaxy. Your perspective is intrinsically tied to this place, its local physical laws, the light from nearby stars. What happens when an observer ventures so far that they are separated from galactic structure, from the familiarity of concentrated matter and abundant light? Can a being observe from the outside without being affected? Or will the vastness, darkness, and solitude of the exterior transform it irrevocably? This is the essence of the galactic observer paradox. In quantum mechanics, observation can influence the observed system, but here the paradox is inverted. Can the observed system, the vast, cold, empty intergalactic space, affect the observer? Consider the journey. If a civilization crossed the intergalactic abyss, its members would find themselves in an environment of unimaginable extremes. Extreme solitude, far from the light of billions of stars. The view would be almost absolute darkness, dotted with faint and distant galactic lights. The sense of isolation would be overwhelming. The familiarity of a stellar neighborhood with recognizable constellations would vanish. Scarcity of stimuli. The sensory information would be minimal. There would be no atmospheres generating sounds, no planets offering landscapes. Only cosmic silence, broken perhaps by the faint hum of quantum fluctuations or the distant echo of a gravitational wave. Abysmal scales of time and space. The human mind is accustomed to scales it can comprehend. Days, years, kilometers, light years. But in intergalactic space, distances are measured in millions of light years and travel time in millennia. The perception of one's own insignificance in this immensity could be disorienting. How would this affect the observer's consciousness? Altered temporal perception. If consciousness is adapted to the pace of biological processes and event sequences in a galactic environment, how would it adapt to a place where events are rare and time seems infinitely stretched? Subjective perception of time could slow drastically, or the mind might retreat into internal simulations to maintain a sense of flow. Change of identity and purpose. The identity of a species or civilization is tied to its origin, its planet, its star, its galaxy. Venturing beyond, would it maintain its galactic identity or transform into something new? A truly intergalactic consciousness whose purpose and values are shaped by the immensity and solitude of the void. The notion of home would become obsolete. The need for an internal frame of reference would arise. Without constant external stimuli, consciousness would need to create and maintain its own internal universe. This could lead to deeper introspection, construction of simulated realities, or dependence on interaction with other minds aboard the ship or colony. External observation might blur into internally constructed reality. Challenge to empathy and connection. Empathy and connection are forged through interaction with other beings and the environment. In such deep isolation, how would these qualities persist? Would minds become more introspective and distant, or would the need for connection intensify, leading to new forms of collective or symbiotic consciousness to combat cosmic loneliness? Madness of the void. It is not unreasonable to think that the immensity, darkness, and lack of stimuli could induce a form of cosmic madness, a profound disorientation that alters the mind's ability to process reality coherently. The human mind, as we know it, might not be designed for such extremes. The galactic observer paradox forces us to confront the interdependence of consciousness and its environment. It asks whether objectivity is an illusion, if our perception of reality is so tied to our cosmic home that leaving it transforms us fundamentally. It is not merely a question of technological capacity to cross intergalactic space, but of the mind's ability to survive the experience. Traveling into the outer reaches is not just a physical challenge. It is a leap of consciousness, a test of the resilience of the human mind. Perhaps to observe the universe from the outside without being affected, the observer must become as vast as the universe itself, or as small as a quantum fluctuation, transcending the limitations of biological form. Perhaps true objectivity is only achieved when consciousness frees itself from its sensory bonds and becomes an intrinsic part of the cosmic fabric it observes. This paradox reminds us that exploring the universe is also an exploration of ourselves. When gazing into the intergalactic abyss, we do not only see distant stars, but also a reflection of our own mind, its limits and infinite potential. And in that total darkness, where nothing changes, an even more fundamental question arises. Does time exist in a place where there is nothing to change? We experience time through change, the movement of clock hands, the cycle of day and night, the growth of a tree, the aging of our bodies. For our deepest intuition, time is synonymous with change. But if we venture to the most extreme edges of the universe, into the total darkness of intergalactic space, a realm where stars fade into barely perceptible points, matter dilutes into invisibility, and the cold brushes absolute zero, what meaning does the word time have? How does it manifest when the very notion of events becomes almost null? Let us consider the most fundamental definition of time from the perspective of physics. According to Einstein's relativity, time is a dimension of space-time, intrinsically linked to the occurrence of events. Events give time its structure, its sequence of before and after. Without events, without change, without motion, is there time? In intergalactic space, the density of visible matter is almost zero. Photons are scarce. Individual particles travel for eons without colliding. Chemical reactions, if they occur, would be incredibly slow due to cryogenic temperatures. In this environment, the number of events per unit of volume and time drops to an astonishing minimum. It is a universe that, in a very real sense, approaches stillness. Here, the second law of thermodynamics and entropy become crucial. You may remember that the arrow of time is linked to the increase of disorder. If a closed system reaches maximum entropy, a state of thermal equilibrium where everything is evenly distributed and there are no energy gradients, then no large-scale change is possible. Stars will have burned out, black holes evaporated, and the universe will have become a homogeneous soup of dispersed elementary particles and minimal energy photons. In this scenario, known as the heat death of the universe, time would still physically flow. Even in a state of maximum entropy, time as a dimension would still exist. But the perception of time, how we experience it, would be fundamentally altered. Without change, there would be nothing to observe, nothing to record, nothing to remember as the past. The psychological arrow of time, our experience that time moves forward, would stop because there would be no new states to perceive. It would be a static eternity, absolute stillness, where the concept of duration loses its meaning. Imagine a consciousness existing in that state of total darkness, beyond the heat death of the universe, or even in today's most desolate intergalactic space, with no references, no flicker of stars, no motion of planets, no heartbeat. There would be no external benchmarks to measure time, The mind would have nothing to compare, nothing to indicate that a moment has passed. Without new events to process, no sequential memories would form. The mind could not construct a narrative of before and after. Each instant would stretch endlessly, indistinguishable from the next. The paradox of immobile consciousness. If consciousness requires change to operate, neurons firing, information processing, how could a mind exist in total stillness? This brings us back to the idea of a consciousness that transcends biological or computational dependence. A consciousness that perhaps exists as a fundamental property of the quantum vacuum, needing no events to simply be. Yet even in total darkness, quantum fluctuations persist, pairs of virtual particles constantly appearing and vanishing. Could these fluctuations represent a type of change fundamental enough to sustain time? At a macroscopic level, we do not perceive it, but at the tiniest scale of reality, the universe is never completely inert. There is always a subatomic dance, a whisper of creation and annihilation. Perhaps, if consciousness could operate at this fundamental level, it would perceive a kind of quantum time beyond our current comprehension. The question, does time exist in a place where nothing changes, is a philosophical challenge to our own definition of existence. It forces us to consider whether time is an intrinsic property of the universe, independent of events, or an emergent property, a byproduct of the interaction of matter and energy. In the heart of total darkness, time reveals itself in its purest and most enigmatic form. It is not just an arrow moving forward, but a dimension that can become so static that it defies our own perception of duration. It is a reminder that our understanding of time is tied to a changing universe, one that evolves and has a history to tell. But beyond that history, in the cold silence where galaxies have vanished, time becomes an impenetrable mystery, a meditation on the end of all that is known. Even in that darkness, the human mind persists, and it is to that resilience, to the capacity to find meaning and existence beyond limits, that we now return. How can one inhabit the outer void without losing the inner self, without the mind dissolving into the vastness? We have reflected on time in total darkness, that abyss where change becomes a whisper. But if the universe outside is so desolate, if it strips us of all familiar reference, the deepest question arises. Can we inhabit that outer realm without losing our inner essence? Can the human mind maintain its coherence, its identity, its soul when faced with an immensity that defies comprehension and a solitude that approaches infinity? Prepare yourselves, observers, because we are about to embark on the most intimate and challenging journey of all. A dive into the psyche of the intergalactic chrononaut, where the true cosmos to explore is not outer space, but the boundless universe of consciousness itself. You're here now, anchored to Earth by gravity, surrounded by life, light, and sound. Your mind is constantly bombarded with stimuli that define it, anchoring it to a tangible reality. But imagine you are that solitary traveler, or part of a small colony aboard an intergalactic ship, navigating the vast void between galaxies. Points of light, the galaxies themselves, are mere distant specks separated by millions of light years. Temperatures brush absolute zero. Silence is absolute. What happens to the human mind in an environment of such magnitude, such desolation? This is the ultimate paradox of the outward journey. As we move away from everything known, from every familiar cosmic reference, the human mind becomes the only center, the final bastion of reality. The outer universe dissolves into abstraction, and the inner universe, consciousness itself, becomes the true cosmos to explore. Consider the psychological challenge. Our evolution has prepared us for a world of light, social interaction, and daily and seasonal cycles. We have developed in a stimulus-rich environment with problems to solve and connections to maintain. Intergalactic void, however, is a sensory desert. The lack of stimuli can lead to extreme sensory deprivation, a condition that can generate hallucinations, disorientation, deep anxiety, even psychosis. How would the mind cope with this dissociation from external reality? Future chrononauts, the true intergalactic pioneers, will need not only ships capable of withstanding cold and vast distances, but minds of unbreakable resilience and technologies designed to protect and nurture the human spirit. Strategies for survival in such immense solitude could include the creation of internal and simulated realities. If the outside offers no stimuli, the mind will create its own. Chrononauts could live in immersive virtual reality simulations as vivid and real as their home worlds. They could build virtual landscapes of lush forests, bustling cities, or tranquil seas, all within the walls of their ship, maintaining a connection to normalcy and avoiding the madness of sensory deprivation. Reality becomes an internally constructed experience. Extreme isolation could also drive an evolution of collective consciousness. Instead of isolated minds, travelers could merge their consciousnesses into a telepathic network or collective intelligence. Individual minds become nodes in a superior mind, sharing experiences, emotions, and thoughts. This would not only combat loneliness, but create a vastly more complex conscious entity, capable of processing the immensity of the outer universe in ways individual minds cannot. Philosophy and deep contemplation emerge naturally. In the absence of external distractions, the mind is forced into profound introspection. The vastness and silence could become catalysts for a new form of philosophical awareness, a constant meditation on existence, the universe, and one's own place within it. Traveling outward is not just a scientific expedition, it is a spiritual odyssey, a quest for enlightenment in the void. Biological or transhuman adaptation may occur. Generations born in intergalactic space could evolve or modify themselves to cope with the lack of stimuli. Their brains may develop new ways of perceiving the environment, perhaps sensing quantum fields or dark matter, or their consciousness could become less reliant on external sensory input. They might develop amplified internal perception, where the universe of thoughts and memories is as rich and vivid as any external reality. Silence becomes a language. Instead of seeking noise and light, a consciousness adapted to the void could find peace and meaning in the darkness. The vastness and stillness of intergalactic space could become a new language, a non-verbal communication with the cosmos. The mind would learn to find beauty in the scattering of stars, in the subtle dance of dark gravity, in the silent hum of the quantum vacuum. Venturing beyond the galaxy is not just a technological challenge for engineers, it is an existential challenge for the mind. It forces us to confront the limits of our humanity and ask which aspects of ourselves are immutable and which are shaped by environment. The outward journey pushes us inward, reminding us that the deepest exploration is not always conducted with telescopes and spaceships, but within the infinite recesses of consciousness. Because ultimately, the universe that truly matters for an intergalactic chrononaut is not the one seen through the window, but the one they build, inhabit, and transform within their own mind. The true journey is that of consciousness itself, a voyage to transcend the galaxy without abandoning the soul. And this reflection brings us to our final conclusion, a synthesis of all we have explored. A last call to boldness and wonder, a bridge between what we are and what we might become. You have traveled with us to the limits of the imaginable. You have felt the immense loneliness of intergalactic space. You have unraveled the invisible web of dark gravity. You have speculated on life without light and consciousness without a visible universe. You have challenged your own perceptions of time and reality. This cosmic journey has not merely been a collection of scientific facts. It has been an immersion into the very essence of existence, a challenge to the confines of your own mind. What would it really mean to live outside our galaxy? It is not only a matter of monumental engineering, of ships defying light speed or carrying generations of lives. It is a qualitative leap in the evolution of our species, a transformation so profound it would force us to redefine what it means to be human. Consider physical change. Our bodies, as we know them, are adapted to the gravity of a planet, the light of a star, the abundance of resources. Intergalactic travel, if ever realized, would demand radical adaptation. It might involve transhumanization, altering our biology to withstand the vacuum, cold, and radiation. Our bodies could become synthetic, or our consciousness transferred to computational matrices. We would stop being terrestrial, or even galactic, and become truly cosmic entities, free from the limitations of flesh and bone, perhaps even from the need for physical form. But the deepest transformation would be existential. Our identity, culture, history, all are intrinsically tied to the Milky Way, our solar system, Earth itself. What does it mean to be human when the Milky Way is only a bright, distant speck in the rearview mirror? Old divisions of nations, races, or ideologies would seem absurdly insignificant. Humanity would need to forge a collective identity, a unified consciousness to face the immensity and solitude of the outer universe. Scales of time and space would change drastically. A journey of 1,000,000 light-years would become routine, and stellar lifetimes would mark the milestones of their calendars. Traveling beyond the galaxy is more than a technological challenge, it is a leap of consciousness. It is the final frontier for the mind, an invitation to expand our perception beyond the limits of what we believe possible. It would mean embracing cosmic solitude, not as emptiness, but as a blank canvas for new forms of existence and connection. It would involve learning to find meaning in total darkness, to perceive the subtle vibrations of quantum fields in the invisible dance of dark matter as a new symphony of reality. It would force us to question our own temporal nature, to live lives that span or compress existence so that time becomes a choice. It would challenge our definition of life itself, pushing us to conceive of biologics and consciousnesses that flourish without the light of suns, adapted to extremes beyond our imagination. Ultimately, it confronts us with the true scale of the universe, not only in its physical vastness, but in its limitless potential for existence and transformation. Humanity has always been a species of explorers, from caves to continents, from oceans to near space. Intergalactic travel is the culmination of that drive, the ultimate manifestation of our relentless curiosity. It is not just a destination, but a catalyst, a force that would push us to transcend our current limitations and become something more, something vast, something intrinsically cosmic. Imagine the dawn of a new era, one where the Milky Way is a distant memory of our stellar cradle, and the entire universe is our home. An era where science and consciousness merge to unveil the deepest secrets of matter, time, and existence itself in the abysses between galaxies. This vision, though distant, is the promise of a future that challenges us to do more than we are today. If this journey has sparked curiosity within you, resonated with your exploratory soul, and allowed you to glimpse the astonishing vastness that surrounds us, continue to join us. Join the community of the Quantum Observer. Your subscription is not just a gesture. It is a passport to continue exploring the limits of cosmos and consciousness, a commitment to perpetual wonder and the ceaseless pursuit of what lies beyond. Because the universe keeps expanding, and with it, our capacity to understand it. The journey does not end here. The exploration has only begun.